Okay, we're live. Okay.
Want some trees? Look how many packets this is.
There's a lot of trees.
I'm gonna count how many things I use in each packet.
I would love you to do the following math problem.
I tried.
Estimate how many trees
Oh.
that is.
How many pieces of paper does one average tree need?
That's a great.
Like actually.
Yeah.
Figure that out.
Yeah.
I would love to know. You don't even know. You're gonna Google it? Oh.
Come on.
Look, I need to use this packet. Wait a second.
How many pieces of paper are in an average tree? See how it does.
Is that really cut it open?
Or produce it from. Since trees are different sizes, it's really difficult to say.
That's why I said the average. Oh my gosh.
Tree.
But it's not a lot of paper.
90,000 sheets of paper.
Yeah, but you know how much that goes, like, how many
So,
pages?
about
Yeah, but
90,000 sheets of paper.
How much paper give us in this class?
Yeah. Actually, I have stats somewhere on how much paper we copy together at school too. Somewhere. We'll just put those side by
We
side.
should
Then
figure
we
out
could
how
actually,
much paper
we
this
could actually,
just our school wastes.
yeah, we get those stats.
And half the people don't even recycle paper, they just throw it away.
No, we have to recycle.
Some people
Half
don't.
recycle.
I understand that. Shame on them.
That's what I'm saying.
A lot of people don't recycle.
A lot of
90,000
And people
pieces.
I've seen
litter.
those like
Okay.
in one tree.
things you guys have to test. Those shipments.
Yeah.
Yeah, report cards. So we're
And we're wasting more paper by giving those papers their.
How's this warm-up coming though?
That's not
It was hard, I tried to.
How was this warm up?
I did too.
All right, I want you to compare your answers with the person next to you. You guys. Boom. You guys.
Wait, you
Boom.
guys
Compare. You guys. Get that for yourself.
Wait, I got 74.
Yeah, okay.
Oh, right, yeah, you're right.
I got one, it's a bigger number. Kind of one, it's like actually.
Square nine.
No, but that's not out of line.
Check for right now.
Right now.
Yeah, and say, this is.
Yeah, I got all the.
All right. What'd you do? How'd these shake out? Okay, well, I'm gonna ask you randomly, starting with Ludo. What do you think on that first one? 2, he says. Is that what you say as well?
Yeah.
Good job. All right. How'd you do that? Just by just looking at it, right? I mean, exactly. But you don't necessarily maybe even have to make too many guesses. I think your first guess on this one will be correct. Yeah. Natalia. Oh wait, she's not here. Okay. Jesse. What do you guys got that second one? Oh, they're getting tricky now. You got that? Okay. X equals 4. Again, I've never asked you how to solve these problems, but he got it right somehow. Did you get that as well over here? Did you discuss it and you got it right? Even if you don't know how he came up with that, you do know that he's right, because you can check it. 2 raised to the 4th power is indeed 16. So good job. Moving smartly along. How about Greg? Ooh. How'd you and whoever you were talking with over here do on that third one? See, I've told you, they're getting a little tricky as we go down the page. You want to jettison that question? Throw it off to someone else who's going to pick it up? Who wants it? Who wants this? Go ahead, please. 0.5. X equals 0.5 or 1/2. Is that correct? Yeah, it works. It works. Again, I don't know how you got it, but we can check and make sure he's right. Right? It is. Is that right? 81. I don't even know how to take 81 to the 1/2 power. How do I do that? Oh wait, I just spent a unit thinking about this. I do know. What does it mean? What does it mean to take something to the 1/2 power? All right, I hear a bunch of mumbling, and I think it's correct mumbling. Yeah, okay. Yeah, it means take the square root. So, yeah, okay. All right, so you,
I thought it was backwards.
it's a 9, sorry. All right, 1, 2, 3, check, check, check. What, friends, about number 4? What about number 4? Anybody help me out on that one? It's easy to ask this question, right? It's as easy as it is to ask the other questions I asked.
Oh, never mind.
Well, what are you doing, those who are trying things and failing? I'd love to know what kind of things you're getting. What are your wrong answers? What kind of good wrong answers do you have out there? What are you getting, Carlos?
I got, I got 23.23.
Ooh, nice, nice. So what are you doing? You made a good guess then as to what x is.
I squared it, but then I put like 2.2 and another number.
Okay, I'm liking what you're doing. Okay, so 4 raised to the, let's start doing guess and check. What might be your first guess, Alan? Make a guess. X equals, I don't know. Make a bad guess, it's wrong. 10. All right, 4 to the 10th is, actually I don't know, but it's really big, right? Wouldn't you agree? It's much bigger than 23. Can you make a better guess? Huh? 5. 4 to the 5th is 1024. Also way too big. Okay, keep, what would you do next? All right, 2. 4 squared is, you know this one. Yeah. Oh, whew. Thought he was gonna get it. 4 squared is 4 times 4, which is, yeah. So too small now. Okay, that's good. We hit the bottom. So 2 is too small. 5 is too big. Can you narrow it down a little more? 3. What's 4 to the 3rd? That's a little harder. 4 to the 3rd is 64. Okay, that's too big. So what have we learned? X is between 2 and 3, right? And then Jesse actually narrowed it down. Sorry, Carlos already narrowed it down even further. He said, okay, well, why don't we try like, what was your first guess?
2.1.
You might. My inclination might be to guess what next. If it's not 2, it's not 3.
2.5.
Maybe 2.5 would be a good guess. Actually, 4 to the 2.5 we can do in our heads. Actually, it's 4 to the 5 halves, which is 2 to the 5th, which is 32. Also, still too big. So 2.5 is a little too big, so it's in between 2 and 2.5. You see how we're actually getting pretty close to this here. And would you say you got a pretty good one? X equals approximately 2.269, and that gets you really close to 23. I'm about to write it down right now to 9 decimal places for you, but I am not going to tell you how I do it. Okay. So this is magic, okay? But to 9 decimal places, this is the correct answer, okay? Here you go. All right. I can't tell you. It's a guarded trade secret, okay? But we were right, I will say. This is the correct answer, approximate answer to 9 decimal places. And it is, in fact, what Carlos said. It's 2.2 whatever. How far did you get? 2.26, you said? Awesome, yeah. But it is between 2 and 3. But it's still a little bit of a mystery. How does one solve a question like that, right? You have no idea what I just typed into the calculator. But it was a lot quicker than guess and check, okay? I won't tell you, okay? Here is the set of answers to your homework last night, and then we will we'll turn our attention to something very new and very, very exciting today, okay? So brace yourself. I will get there eventually. Questions on our homework about E? How did we do on? How did we do? How did it treat you? It was some approximations. At the beginning, asking whether we had growth or decay. I mean, just so you know, you can kind of cheat, can't you, on the growth and decay? If you see a negative sign, it's decay. Okay, let's just say that right now. I mean, we could trick you up a little bit somehow maybe, but that will generally be the rule of thumb, right?
Wait.
What else you got? You simplify these expressions, okay? 24 and 25, you good on the word problems? Please, talk to me. Do you want to talk about any of those? 24 and 25, did you do that? You remember on 24 and 25, you're thinking about this equation we talked about for the first time yesterday. A equals P e to the RT, yeah? Okay, so that's what you're using, like, for instance, on number 24. Compounding continuously, right away, a key word, you should know that that's the formula you're going to use. A equals P e to the RT. Anyone? Anything at all? I'm going to take that to mean that you, like, rocked this homework and you got all the right answers. But is that me being wrong, or that's, you actually did? It's you. By the way, these answer keys are on Edline, and you can check your own answers if you like too, so whatever. So whatever, exactly. Okay, speak now or forever. Hold your peace. Going once. Twice. Sold the man in blue shirt in front row. Okay, here we go. We get to talk, it's so exciting. We get to talk about today logarithms. There's some other warm-ups. Okay, ignore. Logarithms is what we're going to talk about today, or the name of the section is, I think it'll say at the top of your packet, 8.4, logarithmic functions. And yeah, we're moving on to 8.3, because 8.3 we just introduced, well, I'm going to give it to you, it's over there. 8.3 we just introduced the number e and added that into the mix. But there wasn't really that much. It's an amazing number, but I mean, it didn't affect our lives that much yesterday. This will profoundly change your life. So, learning about logarithms. And you remember that Algebra 2, one of our big goals in Algebra 2 is to kind of start introducing you to more and more different interesting functions, right? Logarithmic functions, polynomial functions, absolute value functions, exponential functions, most recently. Before that, square root functions, cube root. We have all these cool functions that hopefully you know how to graph and analyze and think about and use. So today we're going to talk about the logarithmic function, or just the log function for short. That's usually what we'll say. We'll almost never say logarithm. We'll say log. Okay. And even though you don't think it's useful yet, it's my job as your teacher to convince you that logs are extremely powerful and extremely useful and extremely beautiful. But I can tell you right now, whether you care about it or not yet, this is what they look like. Okay. B to the x equals y is the way you've traditionally seen things, like 5 squared equals 25 from the warm-up, for example. But what I'm going to tell you right now is, that even though this might seem meaningless, it's fine if it's meaningless to you right now, you are allowed to, mathematicians will rewrite this way sometimes, right? Either form of these is communicating the same piece of information. Anytime you see this over on the right, you can write this over here on the left. Anytime you see this over here on the left, you can write this over here on the right. Anytime you want. That's what the double arrow means. And let me just give you a little tour of what this says here. We read this out loud as the log base b of y. It's a function, right? So we say the log of y. What kind of log? Log base b. Okay, so this is called a log base b of y equals x. B is a good letter, corresponds to the b over here, and it's called the base of the logarithm, right? And that's a good name for it, because over here, it's the base of exponentiation, right? So it's the same base. B stands for base. Y is sometimes called the argument of the log, so we say the log base whatever of y. equals x. And x, the thing over here, is always the exponent. Do you see it? Okay, so you put the exponent over here. So in a very real and meaningful way, logs equal are exponents. Logs are exponents. That's what logs are in a bumper sticker, one sentence form. And again, let me emphasize, anytime you see one of these ways of writing something, you may write the other way. Okay? You might think, I like the way on the right because that's what I'm used to. But increasingly, you'll start hopefully liking the one on the left as well. Okay? It'll be very useful to you, I promise. Even though you might not understand the importance of this yet, you can rearrange symbols. And that's what we're about to do right now. Anyone still need that last one? Please. Stop me. You good? Anyone? Holler. All right, so this is on the left, logarithmic form for a certain fact that you already know. Again, let's practice reading this out loud. This is log base 2 of 32 equals 5, right, is what this says. The 2 is written smaller. The base of the log is always written a little bit smaller and below the baseline, kind of like a subscript like H2O or something, right? And the number here, the argument of the log, 32, is always written big and on the same line as the rest of the text, okay? So how do we write this in exponential form? Someone want to take it? What would it be? If we rearrange it the way I just said you're allowed to rearrange it. What's the base of the first one? 2 raised to, where's the exponent? 5. 2 raised to the 5th power equals 32. So this is the same piece of information written in logarithmic form and in exponential form. And on the right, you're not comfortable with seeing the one on the left right now maybe, but the one on the right you definitely are comfortable with, right? Aren't you comfortable with the fact that 2 to the 5th is 32? Okay. What about the next one? All you're doing, you don't have to do any math, you're just rearranging symbols. Alan, what would the next one be? What to the what equals what? You got it, right? This to the this equals this, always, right? And by the way, is that true, by the way? Is 5 to the 0 equal 1? Okay, good thing, all right. So this is both columns are communicating the exact same truth. When I see this, I instinctively know, because I've seen logarithms a lot in my life, that this is true, right? You don't have any idea whether this is true or not, maybe. But in that form over there, you can be like, oh, yeah, that is in fact a true statement. Jason, what about the next one? How would you write that? What to the what equals what? Is it? Yeah, well, we're asking, like, over here, 5 to the 0 equals 1. What's going to go over there? Here, 10 to the 1 equals 10. And what about the next one? Oh, wait, she's not here. Megan. Correct? And is that true, by the way? Is that, in exponential form, do you recognize that as a true statement? Is it true that 10 to the negative first is 0.1? It is. See if you can convince yourself that you've forgotten why that's true. Right? Remember what it means to take something to the negative powers? Jonathan, we'll go to the next one. Last one here. Right? And again, can you convince yourself that that's a truth? This is communicating a true statement, isn't it? This is true. 1/2 raised to the negative first equals 2. 2 ways of communicating the same information. Okay. Again, you don't know why it's useful yet, but you do know how to push the symbols around. That's good. That's a great start. That's what we want to have you be at. Just getting comfortable with this other way of writing this. Let's go the other way on these two here. I'd like Nathan. This is right now in exponential form. Can you give it to me in logarithmic form? Log base 5, yep. Yeah, log base 5 of 125. Equals 3, right? Correct. And then, what about the next one there? How about that? What would that be? Log base what of what equals what? Careful, the base is the base. Yeah, log base 10, because that's the base of exponentiation. Right. Okay, are you okay going back and forth on these? Yeah, I think, I don't know. I think I'm going to skip a few here. These are kind of fun. Do you want to do these? Let's do these. That brings a smile to people's faces when they have Fred and Barney in the mix. Okay, so we'll do these. Try and do these quickly. Jesse, I'm going to ask you for the first one, Badoo for the second one, Carlos for the third one, and Mitzi for the fourth one, and you're going to do it right now. Ready? Jesse, go. What's that first one? Up on top, we're doing, I've given you logarithmic form. I want you to write the exponential form. Down below, yeah, I've given you exponential form. I want you to write log form. Yeah. Triangle to the arrow. I love that that's, I know.
I love that that's a hashtag.
I know, it's a
It's a
hashtag.
number sign.
Regardless of what you call it, you're right. Good job.
You're right.
And then,
Yeah.
Badoo, go ahead. 47. Be careful, what's the base?
Oh.
Yeah, and this is a little tricky here. I mean, I'm just being silly here, but it's all of that, actually. That's a little tricky. 5x, all right, to the 47. Good, okay, so all we're doing is simple pushing. In fact, these last two examples show it, right? In fact, we can even do crazy ones like this. So, who's doing that one? Carlos, first one there. Here, number 3. Log base. Uh-huh. Okay. And Mitzi, get the last one for us. Of rocket equals 9. Beautiful. All right. Good. You have no idea what this means, but you can do it. Good job. Okay. All right. Now let's see if we can fill in the blank. All right. So now I'd like you to actually evaluate the logarithm for the first time. All right. Here we go. I'm asking you to evaluate the following logarithm. Log base 3 of 81 equals what? That's the big question. And when you see a logarithm, here's the thing I want you to do. I always want you to ask this raised to, because the thing we're looking for is what? What's the thing that's missing over here on the right side? It's the exponent. Remember, logs are exponents. So when I ask you what is this log, evaluate it. What I'm asking for is the unknown exponent, right? What exponent, Mr. Chase? The exponent that turns 3 into 81, right? So can you name it? 3 raised to what power is the question I always want you to ask. Gives you 81. What is it? 4. So anytime you see a logarithm, I want you to ask this question, right? In this particular case, I want you to ask this question. 3 to what power gives you 81? And hopefully the force of having had a whole unit on exponents and things like that will help you here. I hope you know that 3 to the 4th is 81. That would be prerequisite knowledge to be able to answer this question. Once you establish that the answer to this is 4, that's the answer to this question, right here, right? What is the log base 3 of 81? The answer is 4. Okay? You understand how we might evaluate a logarithm? Okay. Let's step it up a notch. Because these questions, this one was not bad, but like this is, does this feel a little bit like the warm-up, by the way?
Yeah.
3 raised to what power gives you 81, right? That's the question we had in the warm-up today. Right. So hopefully you're going to become good at answering questions like the warm-up. That's all these logarithms are. Questions like the warm-up. Okay. This one's a little trickier. I'll just tell you right off the bat here that 0.04, I can help you a little bit here. 0.04 can be written as a fraction, and that will help us a little bit. How would you write that as a fraction? That's 4 over 100, right? Which is 1 over 25. So I don't really like this problem, but I'm a little bit more okay with this problem. All right. Okay, but I'm still a little bit scared of it, right? If this was the log base 5 of 25, I would love it to be this problem because this one's easy for me. What is the answer to this one? Log base 5 of 25. 5 to what power gives you 25? 2, right? I know the answer to this question, but that is not the question being asked. It's this one here. So 2 is a good first guess. That's what I would guess first. I would say, I think it's 2, because 5 squared is 25. Oh, wait, that doesn't work. Can we make it flip somehow, too? How about a negative 2? Do you see how we reason through that? They make it sound so easy down here, but I actually have to kind of think it through the way we just did, right? So what does this logarithm evaluate to? The answer is, what is this? It's negative 2. Log base 5 of 0.04 is negative 2. Okay? You're always asking yourself, 5 raised to what power gives you 0.04? Not easy to come up with these, maybe. Feel free to check this on your calculator, right? 5 to the negative second. Try it on your calculator. You will get 0.04. Good job. But it just goes to show they're not always as easy as part A, right? Let's do another hard one. How about this one? I like these. It's kind of like they're little puzzles for you. Again, what question are you asking? Let's make sure we're training ourselves to ask the right question. What question are we asking?
What power of B?
Yeah, 1/2 to what power gives you 8, right? That's the question we're asking. Let's make sure we have that firmly in mind. And again, I kind of don't like this question. I do know the answer to this question, right? So let's start with a question we know the answer to. 2 to what power is 8? I like this question. The answer is 3. I like this question because it's easy and I know the answer already. 3. But that is not the answer to the question we have here, right? Taking a cue from the last one. What might we do? 3 doesn't work, right? 1/2 to the third is what? 1/8, not 8. What else do we need to do? The inverse of that? I like what you're thinking, but say more. What do you mean by inverse?
So like, I'm not sure how to explain it.
So what I'm saying, I'm suggesting you put a 3 here and see what happens. And then that's not going to work, so let's fix it, right? 1/2 to the third would be 1/8, wouldn't it? Isn't 1/2 raised to the third power 1/8? You take the power, you take the third power on top and bottom, so you get 1/8. But we want it to be 8. What gives us a flip with exponents? Yeah, like I said, this is not easy, but the answer is in fact -3, right? What goes right here in the question mark? -3, right? 1/2 raised to the -3rd power is 8. I'm giving you these because you will not have ones that are harder necessarily when we give you a quiz or something. Right? This is the leading edge. We're not going to give you harder ones. Yeah, we can make things trickier than that, right? But you have to be, I mean, just to be clear, like what would the answer to this be? Because I want to make sure you're saying the right thing here, Carlos. What is log base 1/2 of 1/4. I want to know what is 1/2. What one half raised to what power gives you 1/4? It is in fact, it's just 2, right? Not -2 or anything. So I want to just make sure you're careful on it, right? But yeah, if you're flipping something, then you could say it that way. Yeah. Just use your rules of exponents, right? Okay, one more tricky one, and then we'll move on to something else in a second. How about this one? Again, we're asking what question? Don't say it, but don't, yeah, if you figure this out, don't give it away. Everyone, no, you're not allowed to give it away. But Amanda is ready whenever you guys want. She'll give us the answer, she said. She has the answer. Figure it out yet? Coming up with that, what's the question, at least, that you're trying to answer?
What power of
This particular case. What power of what?
9?
Yeah. Gives you
5. 3.
3, right? Can you answer that? What do you think? What power of 9 gives you 3? It's tricky. Don't answer. Chantel knows though. You know Chantel? A half. Does that work? 9 to the 1/2 gives you 3. Is that right? She's right. 1/2. Intense, right? These can be tricky. Like I said, it really requires that you be familiar with all these properties of exponents, that they just kind of be near and dear to your heart now, you know? So how does this evaluate? We say this is equal to the number 1/2. Right? Don't just ignore that, okay? 2 properties I'd like to share with you. I'm going to box them. You don't need to write everything down here. Here it is. Boom, 1, and boom, 2. Second property. The first property says, cryptic, that the log base b of 1 is 0, regardless of the value of b. Does that make sense to us? Let's try it. Let's come up with an example. Log base, what's your favorite number, Logan? 2. I love 2 as well. Log base 2 of 1 is equal to what? You tell me. 2 to, what are we asking? 2 to the what? Equals 1. 0. Okay. Right, do you guys agree with them that 2 to what power gives you 1? The answer is 0. Good. And what's your favorite number, Amanda? Log base 8 of 1 is equal to what? Yeah. We're asking, remember, 8 raised to what power gives you 1, right?
Yeah.
So what do you have to, how? 8 to the, gives you 1. All right, my favorite number happens to be, it's my turn. My favorite number happens to be 248, okay? And I'd like to know, what is the log base 248 of 1? That is to say, 248 to what power gives you 1? Are you catching the pattern here? The reason this should feel familiar is because this is a log property, but it's also an exponential property which you know and love. Isn't it true that anything to the 0 power is 1? Okay, so that's why this is happening. The other one that should be kind of somewhat common sense to us is, I haven't heard from you yet, Brianna. Here, give me your favorite number. 3. What is the log base 3 of 3? Riddle me that. Ah, very good. 3 raised to what power gives you 3? The answer is 1. And again, my favorite number is 5,428. What? I got a lot of favorite numbers. Okay. What does that equal? 5,428 to what power? Oh, big mystery. Gives you 5,428. Of course, that's always 1. So these formulas, these properties are hopefully ones you don't have to memorize. They should also just kind of be common sense, right? You just want to be on the lookout for those. Different patterns we see. That's what we're doing. We're mathematicians. We look for patterns. Okay, I think you'll be okay on the homework tonight. Which I'm asking you to do is on the front of a new packet here, just these front problems right here. Okay, so you don't even have to break the binding on this packet. Are you coming back up here, Jeff? Yeah. Okay, there's your packet. And we will say a lot more tomorrow about these. We'd like to, for instance, we'd like to graph logarithms too. That would be fun. Wouldn't it be fun? There's lots to do. Good. When's the next break?
Summer. I'm just gonna go week by week now.